welcome. My name is Michael, and today I'd like to talk about serverless containers and in particular how to run these in Google Cloud Run. I'm a IT consultant and developer, and I live in Nuremberg, and my main focus in the past over my 10 years of experience was web applications. That's what I typically do. I typically work in front ends as well as in back ends, and I work for an IT consulting company called Centric. We have multiple locations in Germany and also in other European countries. My goals for today would be to give you a first impression about serverless containers in Google Cloud Run, and also enable you to explain it to your colleagues on a high level, which for me means you have kind of understood the basic idea behind it if you're able to explain it. And I also want to help you decide if you need to learn more about Google Cloud Run and serverless containers or not, if it's not interesting for you at all for the future. I don't really like the term serverless at all. It's not like there aren't any servers running for this cloud execution model. Like there is something running, but we can definitely talk about the promises or quality attributes of serverless applications or service offerings. They promise a high elasticity and scalability, which means like elasticity is more, you can handle a short-term peak, like think of a Black Friday or other temporary event where the load is extremely high, and scalability is more the long-term. That you're also able, if your customer base grows, then the load will always be over time also grow. And serverless offerings typically promise you to be able to handle both of these aspects. And typically serverless functions or services are driven by some kind of event. It's typically a HTTP request you are getting, but there are also other options. And for me, one of the main selling points is also the low maintenance effort. Usually you don't have to take care of operating system upgrades or other low-level aspects of your service. You can focus on what matters to your business. And this is also underlined by the pricing model they typically offer. It's more based on usage, like your actual traffic you are having. It's less like based on particular machines you are reserving or like other aspects. And so you could hopefully couple this also to your what you're earning as a company. That's hopefully also based on the usage of these services. And Cloud Run is an option to run container images in a serverless way. It's a managed service that's available in the Google Cloud, and under the hood, it uses Knative. Knative is a way to execute serverless workloads in Kubernetes, which is my preferred way to deploy services, Kubernetes in general. So I was a bit skeptical when I first encountered Google Cloud Run, because I was, okay, if I have Kubernetes running, why would I use something like this? But it was a project at the beginning of this year where we didn't have somebody running Kubernetes for us. And I definitely don't want to run Kubernetes myself. It's like I have too much respect for it, and I'd like to focus on other aspects. Yeah, you can configure these containers with environment variables like you would expect. And you can also use secrets. In Google Cloud, there's a secret manager you can use. Unfortunately, the secret manager is also the only way how you can provide like files, configuration files, for instance, to a container, which can be a bit annoying because not all configuration files are confidential, so it feels like a bit stupid to use secrets for such non-confidential configuration files. That's one of the pain points I have so far with Google Cloud Run. And you can invoke such a container-based service, which HTTPS, WebSockets, or a remote procedure implementation from Google. Yeah, and like you can just basically select the container. You don't have to specify much. And if you want, make it publicly available with a HTTPS endpoint. You don't have to worry about certificates or something like this. Yeah, but of course you have some configurations as well to be more granular and, for instance, make it private. One restriction you have that like one service call cannot or shouldn't exceed 60 minutes. Like this is hard timeout, the maximum you can configure. Of course, you can also configure lower timeouts if this is more suitable for your applications. There are also Cloud Run jobs, which are less like services. But this is a preview, and I haven't played around with it yet, so I don't want to talk about it right now. Just in case you need an option for longer execution times, maybe the jobs are an option. They also have the 60-minute timeout, but you can maybe have multiple jobs that you combine to handle like some kind of long-running batch job. For instance, that's something I think of when I think of such long-running times. If you look at the Google Cloud, you have two main alternatives, I would say. Of course, if you consider virtual machines, you have a lot more, but the main alternatives are cloud functions, which is what I traditionally think of as serverless, which is functions as the service. You just have a single function that can be called. It's based on an open source framework, but at the end, it's still limited to basically the Google Cloud, I would say, of at least it's a Google framework, so it's not really that portable, I would say, at least compared to Cloud Run, where you have a container. There are so many options to run containers. That's why I would consider Cloud Run more portable. One advantage over Cloud Functions is also that a Cloud Run instance can handle multiple requests at a time. For Cloud Functions, one request can only handle, or one instance can only handle one request at a time. Both have in common that it's pay-per-usage, and it provides the scalability and elasticity I talked about. The more complex solution would be Kubernetes, I think. It's also pretty similar to Cloud Run in a way that it is container-based. By default, I would say Kubernetes isn't really serverless. Like your container has to run all the time, typically, or you also have such run to completion containers, maybe. But there are also options if you like the serverless model to use Knative as well, which Cloud Run is also based on, and use this to run your services. And yeah, the main difference here, I would say, is that you kind of have to define some kind of scaling. I want this many machines, my cluster has to be this size with this memory and CPU. I would say this is the main pricing factor for the Google Kubernetes engine in a simplified way, which is, so you have, I would say, some baseline of what you have to pay, independent of what your actual workload is. Your container images have to come from the Google registry. either the container registry or the artifact registry. The container registry can be considered deprecated because the artifact registry is more general purpose. You can also upload other artifacts than Docker images. That's why the artifact registry is recommended. It can be another Google project. Typically, it's the same project where your actual service is running. And compared to cloud functions, you have basically all Docker images, so Open Container Initiative images that are supported, which enables you write a range of programming languages, frameworks, and such. There are three main ways how you can deploy a Cloud Run service. You can do it via the Google Management UI, the Cloud Console. You can click it and define name, select the image, and so, and click create. And a minute later or less, the service is up and running. I think to get started as a Hello World, it's fine. But if you're running like a production grade service, you probably want to have something you can integrate into a CI/CD pipeline. And there, I would is the Cloud CLI, which is a command line tool to operate with Google Cloud Services as an alternative. And my personal favorite would be an infrastructure as code tool, for instance, Terraform or Pulumi. There are a few Terraform providers mainly so far. There's an implementation for Google Cloud Run services, and in my opinion, it's a good alternative because typically when you're on the cloud, it's not the only thing you're running. You have also other infrastructure aspects or services you're using, and so you can manage all of these if they depend on each other in one Terraform project, for instance, and really keep everything consistent. And for instance, change dependent things with one commit. I would say that the scaling is quite suitable for most applications. You can really assign many CPUs and much memory for a given instance. And there's an auto scaling implemented. You can define like your minimum and maximum instances. For instance, if you have a service that isn't used that often, you can also say, I want minimum 0 instances, which means if there aren't any requests incoming, there's nothing running, nothing causing costs at all. That's really a cool aspect of it. But it depends really on your type of application or traffic, if this is suitable or not. Maybe you want a fast response time all the time, because if an instance has to be started, this is called a cold start. This can take quite a bit depending on what you're using. And maybe if you have something that's customer facing or user facing, you don't want this to take this long. At the end, these 1,000 instances, it's not really the upper limit. It's actually lower. It depends highly on the region and how you configure your CPU and memory requests for a given instance. So you have to reduce it. But as I said, I think it's suitable for really a lot of applications. And there's even an option to ask Google to increase your quota. I'm not sure how much they are actually offering if you are asking. I like to talk about the life cycle of a given instance of such a container. It depends on what you configured as your maximum and minimum instance. For instance, if you're starting a service and set a minimum 1 instance, then when you're deploying it, there will be an instance started. So the minimum number of instances needs to be available. This is something the scaling takes care of automatically. You can also configure how much concurrent requests your container or your service can handle. And depending on this configuration, the managed service will decide to spin up more instances. One other aspect is also the CPU utilization. Like there's a goal of or target for 60%. And if all of the existing instances have such a utilization, the cloud will start additional instances. And if there aren't any requests incoming for a given instance, it will be shut down after 15 minutes. Here's also a visualization. Like there are two options how to allocate a CPU. Like you can allocate it per request, which is the default, or always allocate it. Here you see in red, there are two requests. And you see in the first model, in this part, you wouldn't, you're not required to pay. This would not be counted as billable time. Whereas when the CPU is always allocated, you would have to pay for the whole life cycle of this instance. Both options are valid depending on your traffic. Like if you have a steady flow, even the always allocation can also be cheaper or more suitable than always allocate than only allocating it for requests. But for my use case, I had the first option was the best because we didn't have that many requests, and most of the time there weren't any requests, and it was rather rare. So summarizing, these are the two options you have for the CPU allocation, like always or per request. This also has an impact on the billing. Yeah, I kind of already mentioned it in the other overview. You have to consider also that when you allocate the CPU always, you also have to pay a lower rate than compared to the other alternative, which can make it also more attractive. But as I said, you have to look at your traffic, and then hopefully you can decide which model or option is more suitable. Yeah, I selected a few random Google Cloud services that might make sense to integrate, but of course there are a lot more. I promised you low maintenance effort for something serverless, and for a Cloud Run service, you get a basic logging and monitoring integration. If you log something to the console, for instance, standard out, you will find it in the Google Cloud logging automatically. You also have some basic request logging. You see which requests are incoming, and also can find errors rather easily. But you can also customize it. There's a specific log format. If you want to do structured logging, you can log something as JSON, and if you adhere to the expected format, you can really customize it quite well. So that's for my use case, I didn't need more than this. And yeah, in addition to the logging, you can also do some basic monitoring. You have a simple dashboard, and also are able to configure alerting, for instance, for errors that occur. You can really combine, for instance, like errors. You can log these as errors and have an alerting on these. Like you need some kind of trigger for your Cloud Run services, and sometimes you don't have requests, HTTP requests. You can, for instance, you have maybe some kind of cron job And for this use case, this cloud scheduler would be an option. I also like relational databases, and there you could integrate Cloud SQL. There's also something you have to consider concerning virtual private networks. Typically, or if you're in the cloud, typically you want to have everything in a private network, a so-called virtual private cloud. And your cloud run services are not, you cannot really put these into such a VPC, but you can enable the access to VPCs. That requires a special connector, and that's also something you might have to do if you're accessing Cloud SQL databases. When you deploy a Cloud Run service, you get some default endpoint. You can reach the application, but maybe to be more flexible, you want to have some API gateway so that you can replace the implementation. And also already mentioned the secret manager for configuration and particular credentials. I also looked at other clouds, and for me, it looks like all major cloud providers have a similar offering. I haven't tried any of these, so I'm not able to judge which is better, but I hope that these are compatible or comparable solutions, so you don't have to be sad if you're in another cloud. Maybe some personal recommendations from my side. Don't take them too seriously. I want to try to give you some guidelines. When you might want to use Cloud Run, I would say it's very suitable for greenfield projects, in particular if you don't really know how much it will scale, how much traffic there will be. This is something where Cloud Run might be really suitable. Also, if you're already in the Google Cloud, it might be a good fit. And what I also like about the container-based model is that you can use existing Docker images you didn't build yourself that are already available, like standard software. And maybe quite few points where I wouldn't really consider Cloud Run. If I have a well-managed Kubernetes cluster, I think I wouldn't consider Cloud Run. I feel like if the cluster is already there, I would rather use Kubernetes, but that's a personal opinion, I would say. And I think it also might not be a reason to switch your cloud provider. If your cloud provider has a similar offering, or if you're happy there, I think it's not the reason to switch your cloud provider. And it's a bit vague, but if you have an application that has a really long startup time, that also might not be suitable for such a serverless execution model. And also, as I said, like long-running workloads. If you're getting close to the 1 hour timeout I've mentioned earlier, it's definitely not a good option. And maybe your application or service you want to deploy doesn't have a suitable API at all. I don't know, maybe some kind of command line tool or whatever. You somehow need to be able to trigger it, and that might be a criterion why you're not why Cloud Run might not be suitable. And of course, you can have multiple Cloud Run services that interact with each other or are dependent on each other, but there isn't much concerning the deployment which you're getting as support. If I think of, for instance, like an Helm chart where you have multiple containers that are dependent on each other, of course you could build something around it and somehow orchestrate your multiple containers with Cloud Run, but it doesn't feel right to do this, I would say. I prepared a little case study to kind of demonstrate how you could use Cloud Run. And I'd like to quickly introduce you into this case study. It's loosely based on the projects I did at the beginning of the year. So we're talking about a European e-commerce company, and we are in a department that is responsible for the inbound logistics, which means they're selling something and somehow they have to get what they're selling. And this has to be typically imported from Asia and is shipped with containers, and typically arrives in Hamburg or Rotterdam in a harbor. The customer already has a supply chain management solution in place, but this solution doesn't have any tracking, so they don't really know where their containers are or shipments are. And they also use multiple transport service providers and are dependent on these providers to keep the shipments in their system up to date. So also they don't really know when something arrives or not, and also are reliant on these transport service providers to provide this data. And the goal for this project was to keep the shipments up to date automatically. And what the people in the company were mainly interested in was the estimated and actual time of arrival and departure. And it was surprising to me how many departments in the company were reliant on that information. Like, it wasn't only the logistics department, it was also like people who were promoting products. Like, they need to know when it's arriving, the products are arriving, and when they are available for sale to really promote it at the right point in time. And also, like, concerning payment and financial services was also a department that was interested, because like the relationships or responsibilities, ownerships in like the sea freight business can be quite complex. And when you have to pay something, can be dependent on where your shipment is. If the shipment is on board of a ship already, for instance, this can be a point where a bill needs to be paid because the responsibility or ownership has already been transferred to the buyer. And I have a proposed solution for this scenario. Somewhere I want to get the data out of the existing supply chain management system. It's not really an option to replace it, because it has only been introduced a few years back, and there's no way they will replace it. But we are interested in the shipment data, which are mainly the container number, some details about the shipment. Yeah. And then I want to store this in a database. I really like PostgreSQL as a general purpose database. It not only supports relational features, you can also work more in a document-oriented way, and you can also use geo data, which might be particularly interesting for this use case with PostGIS. Is like an extension for PostgreSQL to handle geo data. And I don't want this database to be public. I want this only to be accessible within the cloud and keep it private. This is something that might become interesting later. We'll come back to this. And I want to have 3 cloud run services. Due to this private IP, it's not that easy to access the database at all, but I also don't think I actually need it all the time. So there's a concept of debug containers, which are containers you only deploy temporarily, and you start it when you need it and shut it down when you don't need it anymore. And I want to have something to administrate the database, such a debug container. I think there should be some kind of business dashboard where you can see the current position of the shipments and also their status. And there should be some kind of service to keep the shipments up to date in the database. Like when the estimated time of arrival, for instance, changes. And to actually track the containers, there are services to do this. You basically give these services the container number and some shipping company identifier. Sometimes the container number is enough, but typically you need container number and something to identify the shipping company. And then these APIs are able to give you the position, details about the ship, and also, most importantly, estimate the time of arrival. Like, this is also a quite interesting topic, like how this is working. There's like, it's quite standardized that basically you are getting the position of all major container ships because the container ships have to have this system. So that's why there are quite a few APIs to provide this. And I assumed that this is a synchronous API. So you always have to request and to get the current position and current estimated time of arrival. And that's why I need some kind of, or that's why I want to use some kind of cron job to keep this up to date, like maybe every 12 hours or every 4 hours, depending on how critical it is to the business. I want to update the relevant shipments. I give you a quick overview of the architecture. Like, you have the supply chain management system, and they somehow publish details about the shipment to PubSub, which is a top messaging system based on topics where you can publish message in a given format. And one way to integrate PubSub with Cloud Run are push subscriptions. Ignore the Cloud SQL here, it's should be Cloud Run. Like this central tracking service, I made it responsible for storing the shipment data as well as calling the tracking API and keeping the shipments in the database up to date. And I have a direct connection from the dashboard to the database. I'm not saying this is a really good architecture. Probably if you see this, both applications accessing the same database, you might think this might not be the best solution, but I just chose it to demonstrate Google Cloud Run with some examples. And as already mentioned, I have some kind of cron job that triggers the tracking in regular intervals. So this basically means this service has 2 endpoints, or one endpoint with 2 parameters would also be an option. Like one endpoint that is called by the cron job and another one that is called by the push subscription. I will give a more detailed look on the 3 Cloud Run services I mentioned. For this tracking dashboard, I consider this like an internal web application that is only used by employees of this e-commerce company. It doesn't have to be fancy. It doesn't have to be unique or highly customizable. That's why I wanted to use standard software. And when I think about standard software for UI, one thing that came to my mind was Grafana. This is a solution you might have encountered in the operating, like as monitoring, alerting dashboard. But you can also build business dashboards with Grafana. And there's a Docker image for Grafana. So for this tracking dashboard, I don't want to write any code. I only want to configure Grafana in a way. There's, for instance, a plugin for a world map, which is really well suitable to display the current position. And there's also a data source for PostgreSQL databases. So you basically can write queries and display these in given UI widgets to show the estimated and actual time of arrival, departure. I was thinking of some kind of table, maybe with a highlight on shipments that are delayed, for instance. They could be highlighted red. But yeah, I'm really confident that this standard software could fulfill this purpose of this tracking dashboard. You can enable this with files. You take the existing Docker images and provision it with files. Of course, it's not that easy as it sounds. You have to really understand how the configuration files have to look like to get what you want. But I would say you don't really have to write code apart from YAML queries or JSON. For the dashboard, you could, for instance, start the application, configure it as you want, export it as JSON, and then provide this JSON file to your image. Yeah, the painful thing here, as I mentioned earlier, is also providing files to Cloud Run services. Like you have to use Secret Manager to do this, which might make it a bit more painful to maintain these configuration files, which are not always confidential. And for the database access, I want to keep it read-only and also create separate database views that are only used for this dashboard, so that you have at least a bit of decoupling from the tracking service. The tracking service is maybe I should have said it, like Grafana is a web application. You can use it via the browser. The tracking service is a REST web service, I would say, with a custom image. Like you could use anything here. Like something I would think of is maybe like a Spring Boot application, for instance, to implement this. And the images are built somewhere in the CI/CD pipeline and are published in the artifact registry to make these available to Cloud Run. And I mentioned already the PubSub push subscription to keep the shipments up to date, and also to enable the database access, you need this serverless VPC access connector. Yeah, just something you have to keep in mind. It's probably too detailed. Of course, it would have been also an option to make the database public. Yeah, for the database, I mentioned the debug container I want to administrate this private IP database. And for PostgreSQL, there's also a web application to manage these databases, which is called pgadmin. There are also Docker images for it. I particularly chose this example because it's like kind of an case where I'm not really sure if it's a good fit or not. Like this Docker images, this Docker image has tried a long startup time. I think for this use case as a debug container, it's fine. But if you have an application that is user-facing and people stare like for a minute on a blank screen until something is happening, when they first open it, it might not be acceptable. I think for this case, it's fine if these are like operating developers that are people that are using this debug container, so they kind of have to know how it behaves, and you only have to wait once. Like you deploy it, open it, then see a blank screen for a minute, then you can refresh the page, and it is there. But I really like this example as some kind of edge case where it's might not. It kind of shows that there are some workloads that might not be suitable for a serverless execution model. And here I had the same issue with Secret Manager. Like I wanted this debug container to have the database connection already provisioned, so that you only have to log in and have with your user account or some kind of password, and you automatically have access to the database that is relevant. And there are some non-confidential configuration files which I also had to implement with Secret Manager. And yeah, you also have to have a VPC connector to enable this use case. Yeah, maybe having a look back at the architecture again. Yeah, it shows a few selected use cases for Cloud Run there, but there are many more, but there are also many that might not be suitable for Cloud Run. Yeah, I'm close to the end. I can maybe give you some recommendations how you could continue with your journey and Google Cloud Run. There's an Hello World. If we have time, we can also do it together right now. This is basically like clicking in the UI to deploy the service. There's also an employee from Google who was, I think, working on Cloud Run, who has this community-driven project for frequently asked questions concerning Google Cloud Run. There are really some helpful insights and details. If you're working with it with Google Cloud Run, you definitely should read this. And I mentioned Grafana as a particular use case. There's also a tutorial from Google to set up Grafana with like some kind of identity-aware proxy that it's also protected. It's not really, it's a monitoring use case, this tutorial, but just if you're interested in this use case for Grafana, it might also be a good starting point to build a business dashboard. So at this point, I would have time for questions. Otherwise, I will maybe just do the Hello World.
Yeah, what is the name of this the guy that is posting this Google thing?
Maybe take a screenshot. Here's the link that you can follow it.
Okay, right, okay. Okay, thanks.
Yeah, I think we have a couple of minutes left, but in case it doesn't suffice, I will maybe do the ending first and then switch to the Hello World. If you're not interested in the Hello World, it might be a good point to leave. Like you can find me on LinkedIn, Sing, or via email. And if you want to meet me in person, you can also find me on the Cloud Love conference, which is a community-driven conference organized by Kurt that will happen next month in Munich. And yeah, as I said, I will maybe just do the Hello World since we are having some time. This is the Cloud console I mentioned, and if you're looking for Cloud Run, this is basically what you're seeing. I don't have any services deployed, and they have a Hello World service available, or image that I want to deploy. So not demo containers, hello. It's some kind of web application. You can choose a name, region. Let me deploy it in Frankfurt. Yeah, I talked about this CPU allocation, 0 instances. Let's make it up to 4 maximum. All traffic. This is if it's public or not. So this would be public. You can also require some kind of authentication. I will make it public really, and just hit create. So we should be able to find this service when it's available. If you want, you can also access it, maybe cause some traffic on it. Maybe we are also even seeing it in the dashboard. Like this was the overview. We have this one service running. Yeah, here you would see some details about the instances and the scaling. Yeah, I'm not sure why the requests are not displayed, because I'm definitely triggering one. But maybe it takes some time to get the data. Yeah. All right. Last chance for questions, maybe. I didn't see anything in the chat. All right, then. Thank you. I hope you have a great rest of the conference and a nice day.